Binary hashing is a useful approach in retrieval tasks. In large-scale image retrieval problems, we are interested in the k-nearest neighbors of a query image among the images inside the database. The exact search is very slow, and that's why we need binary hashing. Binary hashing is a well-known approach that finds the approximate nearest neighbors of a query image very fast. First, it maps images to the binary codes, and then it computes the distance between the images by comparing their binary codes. This can be done very fast using hardware operations to compute the Hamming distance between the binary codes. To map the images into the codes, we need to learn a hash function h, and a good hash function has to map similar images to similar codes, and dissimilar images to dissimilar codes. Optimizing the objective function to learn good hash function is a difficult task, mainly because the output of the hash function is binary and it makes the objective function non-smooth and non-differentiable. Let's see how we can optimize these objective functions using the auxiliary coordinates. Assume we want to optimize this objective function, which is a popular objective function in binary hashing. Xn and Xm are two images, H is the hash function, Wnm shows the similarity between the pairs of the images, and B is the number of bits. First, we introduce n new auxiliary variables which are binary. Each auxiliary variable is equal to the output of the hash function. Using these variables, we can rewrite the objective function as a new objective function which is constrained and is defined over the hash function parameters h and the binary variables z. Then we apply the quadratic penalty method and we achieve the new objective function, which is not constrained anymore. To optimize this objective function, we start from a small value of mu. We do optimization over z and h, then we increase mu, and we do optimization again, and we continue this process until convergence. How to optimize this objective function over h and z? We use alternating optimization. Optimize the binary codes given the hash function. We solve this problem approximately by using the graph cut algorithm. Then we optimize the hash function h given the binary codes by training b-independent binary classifiers, and we continue this process. The advantages of using auxiliary coordinates. We can optimize the objective over codes and functions jointly, we can achieve a lower objective function value, and we can apply this idea to different kinds of loss functions and hash functions.